So today we're going to talk about section 4.2. Please again go ahead and make sure you have printed off the PDF that I already uploaded to Pause that covers 4.2. Hopefully you've already gone over it, reworked all the problems, put them all in your calculator, and have questions written down. That's the best way to learn, just like you would if we were in the classroom, hopefully. So this first example, and again, hopefully you're looking at your own paper because I know it's kind of hard to see in the video because I'm doing it with my phone, but if you have it printed out, that'll make it much easier, and have your calculator ready as well. So these are homework problems, so hopefully you find them very helpful. This example says the weight of bags of baby carrots are normally distributed. That means we can use the Z distribution with a mean of 35 ounces and standard deviation of 0.29. Bags in the upper 4.5% are heavy and must be repackaged. What is the most a package can weigh and not be repackaged? So we need to take this apart. So for solution, the first thing I wrote down is always write down what you are given. And I kind of highlighted the key words in this problem. If you can kind of see that, I highlighted all the key words. So what are we given? We're told that the mean is 35, standard deviation is 0.29, and the problem is bags in the upper 4.5%. Remember, we always convert to a decimal, move the decimal 2 places to the left, and you get 0.045, okay? And it wants to know what is the most a package can weigh. Well, what is weight in our problem? Weight is the variable, isn't it? So the variable is always X, okay? The variable is always X. So let's look at what we're given again. We need to draw a picture. Here's our picture. Our picture shows the area in the upper 4.5%. So we know that basically if we look right here, the mean is 0. So this is the halfway mark. 50% of the area lies to the right. That's 50%. 4.5% would be a very small piece of it, wouldn't it? Keep that in mind. You don't have to be exact where you put it, but you do know that 4.5 would be over here in the tail. Again, why? Because 50%, this midpoint here where the mean is 0, because we are talking about a Z distribution that we later convert to X. So this is 50%. 4.5% would be over here in the tail, or 0.045. Now, keep in mind, our goal is to find the Z value, In 4.1, we were given the Z value and asked to find the area probability. This is backwards. So let me say it again. In 4.1, we were given the Z value and asked to find the area or probability. Here we're given the percent, which is the area, and asked to find the Z value. The Z value is that point on the axis. That point on the axis. Okay, that's the Z value. And the area, and the upper says above, which means to the right, is given as 4.5% or 0.045. Okay? So that's kind of breaking the problem down. Again, upper 4.5% is right here. We're given area, asked to find the corresponding Z value. Why? Because we eventually want to find weight. If we know Z, we can convert it to X. Remember those formulas? Hopefully you have your formula sheet out and can see those formulas. Okay? But our first goal is to find this Z value. Again, we're going to use our calculator. It's a little different, okay? Because as I have this note here in 4.1, we were given X or Z and asked to find area or probability. Now in this problem, we're given area or probability or percent and asked to find Z or X. So in our calculator, we go to second bars, inverse norm. Okay, so let me pull my calculator into the view. So second bars, okay? In 4.1, we went to normal CDF, but this time we're given area and told to find X. We're doing the inverse, so we do inverse norm. We hit enter. And now what the calculator wants, this is very important, what it wants is, I have it written down, area to the left of Z. Every time you will enter the area to the left of Z, you must memorize this, okay? Because looking back in my picture, they gave us upper area was 4.5%. So this area is 0.045. That's the area to the right. The calculator wants area to the left. Key point, this whole curve has an area of 1 or 100%. Hopefully everybody remembers that. That's a key point we cannot forget. So if the area to the right is 0.045, the area to the left is its complement, 1 minus 0.045. That's what we put in our calculator, the area to the left. Okay, so right here we enter I'm sorry, I messed that up. We enter 1 minus 0.045. And I'm trying to look at the phone instead of my calculator, and I hit the wrong button. 1 minus 0.045. And after that, we do comma the mean, comma the standard deviation. So, comma, the mean is always 0. Standard deviation is always 1 for the z distribution. Okay, and then we hit enter. And we get 1.69, or we round to 2 decimal places and get 1.7. Okay, so that's where I got this answer, 1.7. Now that is my z value, so let me just show you. That is the number right here on the z distribution, 1.69 or 1.7, depending on how they tell you to round it. That's 2 decimal places. That is, I'm sorry, I'm wrong. The 5 tells us to round that up. 1.70 is rounded to 2 decimal places. Okay, so 1.70 is rounded to 2 decimal places. And that's our z value, but we were asked to find what? Weight. It says, what is the most a package can weigh and not have to be repackaged? So we're asked to find weight, okay? Hopefully you're looking back at your paper and it says to find weight, okay? Well, if we know z, we can convert it to x, and that's what I'm gonna do. So looking down here, here's the formula. That's on your formula sheet, so you were given that. X equals z times sigma plus mu. We found z to be 1.7, sigma is 0.29, and the mean was 35. Those were given. Okay, those were the given values for the mean and standard deviation to convert back to x. We end up with, when we multiply 1.7 times 0.29, hit equal, and add 35 to it, we get 35.49. That is ounces, and that is our answer. That is the most a package can weigh and not need to be repackaged. Because remember, anything above that value has to be repackaged. So again, we draw a picture, we write down everything we know. We were given area. If we're given area and asked to find z or x, we use inverse norm, and we always enter area to the left. We were given area in the upper 4.5%, converted to decimal is 0.045. To find area to the left, it's 1 minus the area to the right. In other words, it's complement, and that's what we entered in the calculator. Okay, and we got our final answer. Any questions, please email me.